Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi, Herman and Corin. So as you both know, I'm a man with a lot of electronics. My home office is kind of a laboratory. I call it an AI lab. But it's that place I vanish into. It definitely is my happy place, except when it's full of cables that are not attached to anything, in which case it becomes a very dangerous trip hazard. I'm trying to figure out the best way to connect stuff for the few months before we move on to our next dwelling. And I'm looking at it's crazy how when everything requires its own plug, one runs out of plug outlets very quickly. So I'm always buying these plug strips like this 9 outlet one that I think, that'll be enough for everything that I have. And then it fills up. Now, my question is not just about the rather mundane topic, even I will admit, of purchasing plug strips, but about fire safety, which I think is much more important. When it comes to connecting a lot of electronics, or even a lot of things that don't have a big volt, I'm never too sure, I'm never too sure what is the safe way to do it and how you know that you are not overloading certain sockets. For example, I'm looking at this plug strip here, hoping that it has the maximum amperage written, but I'm pretty sure that it's 16 ampere, which you see on a lot of these plug strips. I've always heard that daisy chaining plug strips is a no-no. It's a bad idea, and therefore I don't do it. But sometimes I'll put a plug strip on an extension cord. The temptation when you run out does become to add more plug strips, but you might find yourself, I'll describe physically what's going on in my office. So I have 2 outlets. And we're in Israel, so we have these unique 3-pronged outlets, 3 circular prongs that you don't see in other parts of the world. I have 2 of those next to where I work on my desk. And remember, this is a rental, so I'm not sure exactly what the wiring is at the fuse board level. But I get 2 plug strips. I put the UPS into one of those so that I have one plug strip that is running on the UPS. And I put my computer, screens, and I like to have a light on it, so I get my little failover set up that if the power cuts out, I'm actually able to continue working with the desk light plus all my gear. And then the other one I use for everything that doesn't need to be on the UPS, and that's where I'm not sure what one can do if you have more than 9 things that need to be plugged in. So Herman and Corin, those are the nuances of my particular situation. But I'd love to get some clarity from you both, especially if this is quite a fancy thing, this 9 outlet plug strip. But let's say you're just dealing with regular ones. They don't display anything about the cumulative draw on them. So how does one go about figuring out how much load you're putting on the circuit? Because these 2 outlets are coming back to presumably a shared circuit on the fuse box. And you don't want to overload the individual extension cord. You also don't want to overload the socket, but how do you do that when you don't have the information as to how much electricity each one is drawing? I don't think most people are looking to become electricity detectives and are going to realistically measure every single device and its draw and do mathematics. So I think let's try to focus on maybe just a more pragmatic, good enough or safe enough thing without making any definitive safety device. For people who are rigging up connecting different appliances to a plug or extension outlets, what are some tips they can make use of to know that they're not creating a dangerously high load on anything and that they can be a safe user of many, many tech things in their cramped office? Because clearly that's the way to go. Over to you, Herman and Corin.
Hey everyone, welcome back to My Weird Prompts. I am Corin, and I am joined as always by my brother,
Herman Poppleberry, at your service. And we are coming to you from our home in Jerusalem, where, as many of you know, we share a roof with our friend and housemate Daniel.
It is a busy house, especially lately. Daniel has been turning his corner of the place into what he calls his AI lab, and if you could see the sheer volume of cables snaking across his floor, you would understand why he sent us today's prompt. It looks like a scene from a cyberpunk novel in there.
I walked past his room yesterday and I honestly thought a cybernetic octopus had moved in. It is a classic problem for anyone into tech or high-performance computing. You have the gear, you have the passion, but you only have a finite number of outlets in the wall. And in these older Jerusalem stone buildings, finite usually means 1 or 2 per room if you are lucky.
Exactly. Daniel was asking about the pragmatic side of this. How do you connect a dozen different devices to power strips and extension outlets without accidentally turning your home office into a fire hazard? Especially when you do not necessarily want to spend your afternoon with a multimeter and a spreadsheet calculating the exact wattage of every single peripheral.
It is such a vital topic because electricity is one of those things we take for granted until the lights go out or something starts smelling like burnt plastic. And since we are here in Israel, we are dealing with a specific electrical standard that differs from what our listeners in North America or the United Kingdom might be used to. It is now February 3rd, 2026, and while technology has advanced, the physics of copper wire and heat remains exactly the same as it was 50 years ago.
Right, let's start there. We are on a 230-volt system here, and most standard domestic circuits are rated for 16 amps. That gives us a bit of a different math problem than someone on a 110-volt system. Herman, break down the math for us, but keep it simple for those of us who haven't looked at a physics textbook since high school.
Happy to. It is the basic power formula, watts equals volts times amps. If you take 16 amps and multiply it by 230 volts, you get a theoretical maximum of 3,680 watts on a single circuit. Now, for our American listeners, a standard 15 amp circuit at 120 volts only gives you 1,800 watts. So, we actually have quite a bit more headroom per outlet here, which can lead to a false sense of security.
That is a great point. Because we have more capacity, we might feel more comfortable plugging in just one more thing. But the danger is not just the total load on the circuit breaker in the wall. It is the load on the individual components, like the power strip itself or the extension cord. I think people often forget that the power strip is the weakest link in the chain.
Precisely. The first thing people need to understand is that a power strip is not a magical multiplier of energy. It is a splitter. If you have a strip with 10 outlets, that does not mean you have 10 times the power. It means you are dividing that one wall socket's capacity 10 ways. And you have to consider the gauge of the wire inside that strip. A cheap strip might use 14 gauge or even 16 gauge wire, which can't safely carry the full 16 amps that the wall is capable of providing.
And Daniel mentioned that he uses a 9-outlet strip. One of the common misconceptions I see is people thinking that if a power strip has 10 slots, it is designed to handle 10 high-power devices simultaneously. But the manufacturer is often just giving you convenience for low-power items, right? Like having 10 phone chargers instead of 10 computers.
Spot on. You have to look at the rating of the strip itself. Most decent power strips will have a rating printed on the back. Usually, it will say something like 16 amps or 10 amps. If you are using a cheap, thin extension cord, it might only be rated for 10 amps, even if the wall socket can provide 16. That is where the danger starts. The wire in that cord will start to heat up because it is too thin to carry the current you are demanding from it. By 2026 standards, with the high-draw AI hardware we are seeing, a 10-amp strip is basically a fuse waiting to happen.
So, for someone like Daniel who does not want to become an amateur electrician, what is the detective-free way to gauge the load? I know we have talked about the rule of thumb for high-draw versus low-draw devices before.
The easiest way to categorize your gear is to ask, does this device change the temperature of something? If the answer is yes, it is a power hog. Anything with a heating element or a powerful compressor is going to draw a lot of current. Space heaters, electric kettles, hair dryers, air conditioners. These should almost never be on a power strip. They need their own dedicated wall outlet. A standard electric kettle here in Israel can pull 2,500 to 3,000 watts all by itself. That is almost your entire circuit capacity in one go.
What about the tech side? Daniel's AI lab has computers, monitors, high-end graphics cards, and a UPS. Those do not necessarily heat things up in the traditional sense, though they certainly get warm. I mean, his workstation fans sound like a jet taking off when he is training a model.
High-performance computing is the exception to the temperature rule of thumb because of the sheer density of the components. A high-end power supply for a workstation might be rated for 1,000 or even 1,600 watts. If you have a couple of those, plus 3 or 4 large monitors, you are suddenly creeping up toward that 3,000 watt limit very quickly. And we have to talk about the 80% rule, which is a standard electrical engineering guideline.
The 80% rule? Is that like the Pareto principle for electricity?
Sort of. For any load that is going to be running for more than 3 hours, which we call a continuous load, you should only utilize 80% of the circuit's rated capacity. So, if our circuit is rated for 16 amps, we really should not be pulling more than about 13 amps continuously. This prevents the circuit breaker from getting too hot and tripping prematurely, and it keeps the wires from degrading over time due to constant heat stress.
We actually touched on this a bit in episode 221 when we talked about multi-monitor setups. When you have 4 or 5 screens, the idle draw is not huge, but when they all wake up at once, there is a surge. Herman, tell us about inrush current. That seems like something Daniel should be worried about when he flips the master switch on his power strip.
Inrush current is the instantaneous surge of power that happens when you first turn a device on. Capacitors and power supplies need to fill up, and motors need to start spinning. For a split second, a device might pull 5 to 10 times its normal operating current. If you have 10 devices all on one strip and you flick that single red switch, the combined inrush current can be massive. It can actually weld the contacts inside the power strip switch together, or trip the breaker even if the total running wattage is fine.
So the pragmatic tip there is to turn things on one by one, or at least stagger them.
Exactly. Turn on the UPS first, let it stabilize, then the workstation, then the monitors. It is better for the equipment and much safer for your wiring. Now, let's talk about the physical signs. If I am Daniel, and I have everything plugged in, what are the red flags I should be looking for?
The most basic test is the touch test. This is incredibly low-tech, but very effective. After your gear has been running for an hour or so, go to the wall outlet and touch the plug. Then touch the cord of the power strip. It should feel room temperature. If it feels warm to the touch, or heaven forbid hot, you are overloading that connection. If it is too hot to hold your hand on comfortably, that is an immediate fire risk.
Is that because of resistance?
Exactly. Heat is the byproduct of electrical resistance. If the wire is too thin for the current, or if the connection inside the plug is loose, energy is being converted into heat instead of reaching your device. That heat can eventually melt the plastic insulation, leading to a short circuit or a fire. And remember, heat increases resistance, which creates more heat. It is a vicious cycle.
What about the smell test? I've heard people talk about a fishy smell or the smell of ozone. Is that still a thing with modern plastics?
It is actually more common with modern plastics. Many electrical components use urea formaldehyde or similar resins. When they overheat, they release a very distinct, pungent, fishy smell. If you smell something fishy or like burnt electronics, that is an emergency. That is often the smell of the plastic housing of an outlet or a wire beginning to arc and melt. At that point, you need to shut off the breaker immediately. Do not stop to save your work. Just kill the power.
Daniel mentioned daisy chaining. He said he knows it is a no-go, but the temptation is always there when you run out of slots. Why is daisy chaining specifically so dangerous? I mean, if the total wattage is low, why does it matter if I plug a small strip into a big one?
It is about the cumulative resistance and the bottleneck effect. When you plug one power strip into another, you are forcing all the current for every device on that second strip to pass through the first strip's cord and internal connections. Each link in that chain is a potential point of failure. Most power strips are not designed to have their full capacity pulled through a single set of internal copper rails from another strip. Plus, every time you add a plug into a socket, you are introducing a point of contact resistance.
That is a great point, Corin. A loose plug is almost more dangerous than a heavy load. If you feel a plug wobble in the power strip, throw that strip away. It is not worth the risk. Over time, those spring-loaded contacts inside a cheap power strip can lose their tension. If the plug is loose, you get micro-arcing, which generates immense heat in a very small area. This is how you get those charred, black marks on the prongs of your plugs.
So, if we are looking for a pragmatic strategy for a house like ours, how do we balance the load? Should we be looking at which outlets are on which breakers? Because, in this house, I think the kitchen and the living room are on the same circuit, which seems like a disaster waiting to happen if we use the air fryer and the vacuum at the same time.
Yes, if you really want to be safe, you should map out your home. It is a fun Saturday project. One person stands at the breaker box with a phone, and the other person goes around with a lamp or a nightlight. Plug it into every outlet and see which breaker kills it. In many Jerusalem apartments, especially older ones, multiple rooms might be on a single 15 or 16 amp breaker. If Daniel is running his AI lab in one room and someone turns on a vacuum cleaner or a space heater in the room next door, they might both be pulling from the same pool of electricity.
I remember we talked about this in episode 224 when we were discussing how to keep the fiber internet and the UPS running during those winter storms. You have to know your limits. If you know that the bedroom and the office share a 16 amp breaker, you know you can't run a space heater in the bedroom while training a neural network in the office.
Right? And since Daniel mentioned he has a UPS, that adds another layer. A uninterruptible power supply has its own internal capacity, usually measured in volt amps. If you overload a UPS, it will usually beep at you or just shut down. It is actually a great canary in the coal mine. If your UPS is screaming, you are definitely drawing too much power. But you should not use a UPS as your only safety measure. It is a battery backup, not a power distribution miracle.
Let's talk about some of the tools people can use if they want to get a bit more data without being electricity detectives. I am thinking of things like smart plugs or those kilowatt meters. By 2026, these things have gotten pretty advanced, right?
Oh, I love those. For anyone who is genuinely curious or worried, a simple plug-in power meter is a fantastic investment. You plug it into the wall, plug your power strip into it, and it tells you exactly how many watts you are drawing in real time. It is a massive aha moment for most people. You see that your PC draws maybe 100 watts while browsing the web, but jumps to 800 watts the moment you start training a local AI model or playing a game.
And those smart plugs that have energy monitoring built in are becoming so cheap now. Many of them now support the Matter 2.0 standard, so they integrate right into your phone's dashboard. You can set up alerts. Like, if this outlet exceeds 2000 watts, send a notification to my watch.
Exactly. If Daniel put a $20 smart plug at the head of his 9-outlet strip, he could see exactly when he is approaching that 2000 or 3000 watt danger zone. It takes the guesswork out of it. Some even have auto shoot-off features if they detect an overcurrent situation or a sudden spike in temperature at the plug itself.
One thing I have noticed in Daniel's room is that he has a lot of wall warts, or those bulky power adapters. Sometimes they are so big they cover 2 or 3 slots on a power strip. He's been using those little 6-inch extension liberator cables to fit them all. Is that safe? Or is that just another form of daisy chaining?
Generally, yes, those are safe. Those short power liberator cables are fine as long as they are of decent quality. They do not add significant resistance because they are so short. The bigger issue with those large adapters is that they can be heavy and pull the plug partially out of the socket, creating that loose connection we talked about earlier. Using the short extensions to let the adapter sit on the floor or the desk is actually a safer bet than having it hanging precariously off a vertical power strip.
What about the quality of the power strip itself? There is a huge difference between the $5 one at the grocery store and a professional grade one. I see some that say surge protector and some that just say power strip. What is the difference?
It is night and day. A simple power strip is just a piece of plastic with some copper rails. A surge protector includes components like metal oxide varistors, or MOVs, which are designed to sacrifice themselves to protect your gear from voltage spikes. But here is a secret: MOVs degrade over time. Every time there is a tiny spike on the grid, the MOV wears out a little bit. If your surge protector is 5 years old, it might just be a power strip now. High-quality ones have an indicator light that tells you if the protection is still active.
That is a great tip. If the protected light is off, it is time for a new one. Now, Herman, let's talk about the physical layout. If you were going to reorganize Daniel's AI lab today to be as safe as possible, what are the first 3 things you would do?
Number 1. Group by power draw. I would put all the heavy stuff, the PC and the UPS, on one power strip plugged into one wall outlet. Then I would put all the light stuff, the monitors, the desk lamp, the phone chargers, on a second strip plugged into the other wall outlet. This splits the load at the wall, which is usually the sturdiest part of the system. Even if they are on the same circuit, you are reducing the heat at any single point of contact.
That assumes the two outlets in the wall are not just jumpered together behind the plate, right?
Even if they are jumpered together, the physical connection at the wall socket is much more robust than the thin copper inside a power strip. You are still better off splitting them. Number 2, cable management for heat dissipation. Do not bunch up your power cables into a rat's nest behind the desk. Cables need airflow. If you have a bunch of high current cables bundled tightly together with zip ties, they will insulate each other and get much hotter than they would if they were spread out. I have seen bundles of cables actually melt together because they couldn't breathe.
I see that all the time. People want it to look neat, so they tie everything into a tight bundle, but they are effectively creating a little heater. Use Velcro ties and keep the power cables somewhat loose. What's number 3?
Number 3, the physical audit. Once every 6 months, unplug everything. Look for discolored plastic around the prongs of the plugs. Look for dust buildup inside the power strip sockets. Dust can actually be a fire hazard if it gets inside the strip and creates a path for electricity to track across. It is called tracking, and it can lead to a fire even with low voltage devices. Give everything a quick wipe down and make sure all the plugs still fit snugly.
That is very practical. It is easy to just set it and forget it until something goes wrong. One more thing that most people forget: the age of the building. We live in Jerusalem, and some of these buildings have wiring that dates back several decades. If you are in an old stone house, your 16-amp circuit might actually be older wires that have become brittle over time.
That is a critical point. Older insulation can crack, and if you are pushing 16 amps through a wire that was installed in 1970, you are asking for trouble. If you notice your lights flickering when your PC is working hard, or if you hear a buzzing sound from the walls, that is a sign that your home's wiring is struggling to keep up with the demand. That is not a power strip problem, that is an electrician problem.
I have lived in places where turning on the microwave made the computer restart. That is called a brownout, and it is terrible for electronics. If that is happening to you, you definitely need a double conversion UPS, which we discussed in episode 24. It cleans up that dirty power by constantly running your gear off the battery while the battery charges from the wall.
Exactly. It acts as a buffer. Now, let's dive into some of the more edge case questions Daniel had about ground loops and interference, which often go hand in hand with these crowded power setups. This is where the weird in my weird prompts really shines.
All right, let's talk about ground loops. Daniel mentioned that sometimes when he has everything plugged in, he hears a low hum in his speakers or sees a faint horizontal line scrolling on one of his older monitors. It drives him crazy when he is trying to concentrate.
That is the classic symptom of a ground loop. When you have a lot of devices connected to each other via data cables, like HDMI or USB, but they are plugged into different power strips or different wall outlets, you can create multiple paths to the ground. Because the electrical ground is not always at exactly 0 volts everywhere in your house, you get a tiny bit of current flowing where it shouldn't.
And that current flows through your audio or video cables. And because those cables are designed for very sensitive signals, that tiny bit of electrical noise becomes audible as a hum or visible as static. Is it dangerous or just annoying?
Mostly annoying, but it can occasionally damage sensitive components if the voltage difference is high enough. The pragmatic fix is to try to get all your interconnected gear onto the same ground point. That means having your PC, your monitors, and your audio interface all on the same high-quality power strip if possible. But wait, didn't I just say we should split the load between wall outlets?
Ah, the great trade-off. You have to balance the electrical load against the signal noise. For Daniel's AI rig, the load is the priority. If he gets a ground loop, he can use things like ground loop isolators for his audio cables. These are little transformers that physically break the electrical connection while letting the signal pass through. It is a $10 fix that saves your sanity.
It is interesting how everything is connected. You try to solve a safety problem by splitting the power, and you accidentally create a signal problem. That is the beauty of complex systems. There is no such thing as a free lunch. But for most people, the hum is a minor nuisance compared to the risk of a fire.
One other thing Daniel asked about was the switch on the power strip. Is it better to leave it on all the time, or should we be switching it off every night? I know some people are worried about the vampire draw.
From a safety perspective, switching it off is great. It completely disconnects the load. However, for a lot of modern electronics like Daniel's AI servers or a modern TV, they're designed to be in a standby mode. Constant cold booting can actually put more stress on the power supply capacitors over time because of that inrush current we talked about earlier.
So, the vampire draw is the trade-off for longevity? For those who don't know, vampire draw is the power used by devices when they are technically off but still plugged in. It can add up to 10% of a monthly bill in a tech-heavy house.
Precisely. If you are worried about the vampire draw, you can get smart power strips. These have one master outlet, usually for your PC. When it senses the PC is turned off, it automatically cuts power to the slave outlets, like your monitors and speakers. It is a great way to save energy without having to manually flip switches every night.
Speaking of Israel, I want to circle back to the 3-prong plugs we use here. They look a bit like a smiley face, but they are actually quite robust compared to the 2-prong Euro plugs. We call it the Type H plug.
Yes, the Type H plug is unique to Israel, though the modern version has round pins that are compatible with the European Type C. The third prong is the ground. Never ever use an adapter that bypasses that third prong. I see people do this with imported gear all the time. They use a cheater plug to fit a 3-prong American device into a 2-prong socket. You are effectively removing your safety net. If there is a fault inside the device, the metal chassis could become live, and the next person to touch it becomes the path to ground.
That is a terrifying thought, especially in a room full of metal case servers and workstations. Herman, what about travel adapters? Daniel has some gear he bought in the States and some from Europe. Is it okay to just leave those adapters on permanently?
Generally, no. Travel adapters are meant for temporary use. They often have very thin internal connections, and they can easily wiggle loose. If Daniel has a piece of gear with a US or UK plug that he's using permanently, he should really cut the plug off and wire on a proper Israeli 16-amp plug, or buy a dedicated high-quality replacement cable. Most monitors and PCs use a standard IEC cable, the one with the 3 rectangular holes. You can buy an Israeli version of that cable for $5. It is much safer than using a cheap plastic adapter from the airport.
That is a great tip. I actually did that for my last build. It just feels much more solid when it clicks into the wall. Solid is what we are going for. Electricity loves a solid connection. It hates gaps, it hates loose fits, and it hates thin wires.
You know, talking about all this makes me realize how much invisible work our house does every day. We just plug things in and expect them to work, but there is this whole hidden dance of electrons happening behind the drywall. And when you think about the fact that we are now running massive neural networks in our spare bedrooms, the demand we are putting on these old systems is unprecedented. A house built in the 1980s was designed for a TV, a fridge, and maybe a few lamps. It was not designed for a 16-core processor and 3 graphics cards drawing a kilowatt of power 24/7.
It's true. We are basically running industrial-level compute in domestic-level infrastructure, which is why the physical audit I mentioned earlier is so important. If you live in an older home, you are the primary safety inspector. Ermin, any final thoughts on the pragmatic side of power before we wrap up?
Just one. If you are ever in doubt, or if you feel that bit of anxiety when you plug something in, listen to it. That intuition is often your brain picking up on a small detail, like a faint crackle or a slight resistance in the socket. Don't ignore it. Electricity is a wonderful servant, but a terrible master. If a plug feels loose, if a cord feels warm, or if you see a spark when you plug something in, address it immediately. It is much cheaper to buy a new power strip than to replace a house.
Well said, and thank you, Daniel, for sending in this prompt. It is something we all deal with, but rarely stop to think about until it is too late. I think this will help a lot of people who are building out their own home labs or just trying to manage the cable chaos behind their TV.
Absolutely. It was a pleasure to geek out on some domestic engineering. It is the foundation that all our other tech sits on, literally.
This has been My Weird Prompts. You can find us on Spotify, or check out our full archive of over 400 episodes at myweirdprompts.com. We have covered everything from portable power stations in episode 249 to the intricacies of fiber optic reliability.
And if you have a moment, please do leave us that review. It helps the show reach more people who might be wondering if their own AI lab is about to blow a fuse. We really appreciate the support from our community.
Thanks for listening, everyone. We will be back next week with another deep dive into the weird and wonderful prompts you send our way. Stay safe, stay curious, and maybe go check your power strips right now.
Goodbye, everyone.
So, I was just thinking about that 9-outlet strip Daniel has. Do you think he's actually using all 9?
Knowing Daniel, he's probably looking for a 10-outlet one as we speak. He told me this morning he wants to add a dedicated local LLM server just for his smart home.
We might need to have a house meeting about the utility bill soon, or at least install some solar panels on the roof to keep up with his demand.
Or we just start charging him by the kilowatt hour for the AI tax. I think that is only fair given the heat his room generates in the summer.
I like that idea. Alright, let's go see if the kitchen is still on. I think I heard the toaster pop.
Lead the way. I hope the toaster isn't on the same circuit as his server.
Thanks again for joining us, everyone. This has been My Weird Prompts.
Until next time.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.